Hello, it's your friendly graduate assistant, and today we're going to take a few minutes and talk about descriptive statistics. The descriptive statistics is basically using numbers to describe what you're talking about. It's methods used to summarize and describe variables, which is what you study, in order to make the information they deliver easier to assimilate or understand. Descriptive stats are the indicators which describe the general characteristics of variables in the samples. There's three aspects of descriptive statistics. There's the central tendency, which is a measure of location. There's the variability, which is the spread or dispersion. And there's the shape of the distribution. Now, central tendency, that's saying that numbers, if you plot them, tend to go to the middle. You'll have some on the right, you'll have some on the left, but they generally tend to go to the middle. The variability is describing that spread, so that you have some in the middle, you have some on the right, left, top, bottom. The shape, well, what actual shape do those take when you plot them on a number line? Central tendency is the typical value of the variable. It's the most representative value. They indicate the center of the bulk of the values in the distribution when you look at the numbers or when you graph it. There's three measures of central tendency: mean, median, and mode. The mean is the arithmetic mean, or the average, basically. It's the sum of the values divided by the numbers of values. So if you add these up, this number string, and divide by how many numbers there are, you've got the mean. So right here we have a number string that we're going to be working with this evening, and there's 9 subjects. If we lay these out in a data set, okay, now this might be confusing as it's the first time seeing a data set. The position is denoted by the lowercase I, and just have 1, 2, 3, all the way up to 9. Your value is x sub I, which is 3, 6, 7, 6, 7, 6, 4, 3, 12. Basically, if we look at our string of numbers right here, it's no different. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just an excellent way to keep your numbers organized. The computation of the mean, this is kind of a confusing thing. X bar, which means the mean, or the x average, is equal to x sub 1 plus x sub 2 plus all the way up to x sub n. Now don't forget what these number 1, 2 are. 1, 2, 3, all the way up to x sub n. It's just saying you take the value of position 1 plus the value of position 2 all the way up to whatever positions you have, and you divide by n. Lowercase n, that's how big your population is. In our case, it's 9. So to figure out the mean, x bar, or the average, is equal to x sub 1 plus x sub 2 all the way up, divided by n. If you look at the shorthand notation, this is the same equation, just written a different way. You have x bar is equal to the sum of n. I equals 1, so it's a one-place change, divided by lowercase n, which is 9. The median is the middle value when all values are sorted in either ascending or descending order. For an even number, the median is the point halfway between the two middle values when all values are sorted in ascending or descending order. In this case, if we take our same number set and we line them all up, it's 6. Oh, I forgot to mention before, if you solve the mean, it's going to be 6 also. The general definition of median, it's the point which half the values fall, below which half the values fall. The below is an important thing. The mode is the most frequent value in the set. It occurs the most often. If we look at our data string, our mode is going to be 6 because it occurs most frequently, most often. Variability, or spread, is the measure of central tendency to not adequately describe a variable. In addition to knowing the center of numbers, you also need to know how far the values of a variable spread away from the center. Basically, how far they can go to the right, how far they can go to the left. There's 3 common measures of variability. There's the range, the interquartile range, variance, and standard deviation. The range is the difference between the minimum and maximum values. If we take our data string, we look at the top value, which is 12, the lowest value, which is 3, just subtract them. 12 minus 3, as far as I know, is 9. So our range is 9. The limitations of the range, much like the mean, it can be really influenced by extreme values. If we had the number 300,000 up here, obviously our range would be 299,997, but that's not an accurate representation of the rest of these numbers. So it can be really influenced by extreme values. It also only uses 2 values of the data set. It ignores all the other values. But it does give a quick way to assess the variability of the variable. Now the interquartile range, basically that's telling you to ignore the top 25 and bottom 25% of the string of numbers. If we have, a different data set right here, 12 numbers, it's saying 20 minus 2 equals 17. Okay, that's the standard range. But interquartile range, get rid of the top 25%, get rid of the bottom 25%, so your 7 minus 4 equals 3. And you can see there is a distinctive difference in range from 17 down to 3. Most researchers tend to avoid the interquartile range because you lose 50% of the values that you're looking at. I mean, you only have half the data that you're using. It ignores pretty much everything else. The variance is the average of the squared deviations from the mean. If you remember back a while ago, we figured out the mean, and it was 6. So this way, we have our data locations, we have our data values. Remember, our mean is 6, and if you see this equation right here, x sub I minus x bar, which is the mean. So all we have to do, what is 3 minus 6? Well, it's minus 3. 6 minus 6, which is our mean, 0. 7 minus 6, 1. 6 minus 6 is 0. 7 minus 6 is 1, and so on and so forth. We just take our first strings, subtract it from our mean, which gives us this column of answers. Next, we square this column. So 3 squared is 9, 0 squared is obviously 0, 1 squared is 1, 0, all the way up, and then we add them. And when we add these, we get the number 60. To figure out variance, we're going to take that number and divide it by n, our population. So we get a variance of 6.67. So if we look at this again, mean is 6. 3 minus 6 is minus 3. 3 squared is 9. Add them, get the number 60. And right here, divide it by your population, and we've got a 6.67 variance. It's denoted by s squared. In the original terms, you can see we've got our s squared variance. We've got the sum, we've got our population, one change, x bar squared, lowercase n our population, gives us 6.67. Standard deviation is the square root of the variance, denoted by s, and given by the formula. Okay, so this is a little bit different than variance. If you see variance, right here, you've got n, gives you 6.67. Standard deviation is n minus 1. This gives you a more accurate representation of the population, and you take the square root. One of the biggest problems I've always faced with standard deviation versus variance is just n, standard deviation n minus 1, and remember to take the square root. So if we change up the equation, n minus 1, square root, we're left with 2.58. Now, if you look at the distribution shapes, if we take all these numbers and we plot them on an xy coordinate, you have the uniform or rectangular distribution, you have your normal distribution, double exponential, bimodal, positively skewed distribution, or negatively skewed distribution. If we look at this, this is a uniform rectangular distribution. If you had the super class of students and every student scored exactly the same score, this is what your distribution would look like. All of your students identical, and it would be a very, very boring way to research education. Normal distribution, this is called a normal curve. This right here is your center. Standard deviation comes out to the right, comes out to the left. And this normal distribution, pretty much all scores on tests correspond to something like this. You have your large center and the average. Most people are average. You have a few select few that score really well, and you have some that score not so well. You have double exponential distribution, which is instead of a nice sloping curve right here, you have boom. You also have bimodal distribution, which if you're issuing a test and you have a large number of students score, in the 60 to 70% range, you also have a large number of students scoring in the 80 to 90% range, you have a bimodal distribution. You can also have two separate normally occurring curves. Positively and negatively skewed distributions. Picture attendance rates right here for positively skewed. Most students miss, a very few numbers of school. So say this is 1 day missed, 2 days missed, 3 days missed. Most students miss 3 days. But you can see as this goes down, there's very few number of students right here who miss a whole lot of days. So the population goes down as the days absent goes up. You can also have negatively skewed data. Let's say this is daydreaming during, I don't know, a research class or statistics or something. At the beginning of class, very few people are daydreaming because the instructor is amazingly interesting and people are like, wow, I can't wait to learn more about statistics. But by the end, a great deal of students are daydreaming. This is the example of the positively skewed numbers of days absent. You can see, you have a whole bunch of students at the beginning missing very few days, but then as time goes on, you have a very few amount of students missing very many days.